Okay, today we are going to introduce the distributive property and start talking about how we use it to solve problems. So the distributive property is a way of writing equivalent expressions. So the definition is here. It's the mathematical property used to rewrite expressions involving addition and multiplication. The distributive property states that for any three numbers, a, b, and c, a times b plus c will equal a times b plus a times c. So we're taking this quantity and separating it. And this property is used a lot in algebra. So we're going to use the page out of the book. And we're going to take a look at Lila and her conjecture here, that the sum of two even numbers is an even number. And so she models that with square tiles. So she's modeling 6 here with 2 rows of 3. Okay, and she's saying that if we take this, which would be 6, and we add 2 times 5, or 10, we would get 16, which is the same thing as saying 2 times 3 plus 2 times 5 equals the same thing as 2 times 3 plus 5. Okay, now this is correct. Okay, Alex wondered if this means that 2 times 3 plus 2 times 5 would equal the same thing as 2 times 3 plus 5. So if we take this over here and we say 2 times 3 plus 2 times 5, we would get 2 times 3 here is 6 plus 10, and that equals 16. But if I take the distributed form of that and say 2 times the quantity of 3 plus 5, then we're going to, we basically solve it using the order of operations, which we would do the inside of the parentheses first and get 2 times 8, and 2 times 8 equals 16. So this is a product and this is a sum. And we can use both of them. Now in algebra a lot, we'll put a variable in for one of these numbers, and therefore we don't always have all of them being numbers. So there's two ways that we can write the distributive property. We can write the distributive property as the sum of two terms, which is right here. This one is the sum. Or we can list it as the product of two factors. So the green represents the product of two factors. So this is the sum of two numbers. This is the product of two factors, 2 and 8, and then 6 plus 10. All right, so we're going to move on. Okay, so I'm going to take a look at some problems in our book here, and we're going to apply the distributive property to them. So a lot of times when we're introducing the distributive property, we're going to talk about a rectangle model or a area model. Okay, so what we're going to do here is we are going to take a large rectangle and cut it into two smaller ones and then show two different ways to calculate the area. So right here I have a large rectangle. Okay, and then on this dotted line it's cut into two smaller ones. It's cut into this one here plus this purple one. Okay, so identifying the lengths of each side, this side right here is 5 and this is 4. Okay, and then all I did was count up the squares. So again, 5 and then 1, 2, 3, 4, 5, 6, 7, 7 there. So what we are showing is that 5 times 4 plus 5 times 7, I better put that in purple, that way the colors are matched. Okay, 5 times 7 is going to equal the sum of the 5 times 4 plus 7, because this is all on the same side. So that would be 4 plus 7. Okay, now let's take a look at these. If I take 5 times 4, I get 20. And then if I take 5 times 7, I get 35. And so the sum of that would be, the total would be 55. So my area is equal to 55 squares or square units. Now, if I come over here to this side, or the green side, I get 5 times 4 plus 7. So I'm going to do what's in parentheses first, and I would get 5 times 11, and that equals 55. So they equal each other. Okay, and again, I'm writing it two ways. One, I'm adding 4 times 5 to 7 times 5. And the other way, I'm going to add the two terms inside the parentheses first and then multiply to solve. So let's take a look at another one. All right, right here we have a rectangle that's 2 this way, and 1, 2, 3, 4, 5, 6, 7, 8 this way. So if we just multiplied 2 times 8, we would get 16. Okay. However, because we are cutting it into two smaller rectangles, okay, we have this one and this one. Okay, we now have a 5 here and a 3 here, and that 8 is it's there, but it's we've cut it into two different parts. So now what we have is 2 times 5 plus 2 times 3, or we could add them together and say 2 times 5 plus 3, so that we get the 8. Okay, so this is really just writing this out as the sum of those two numbers. So either way, we get 10 plus 6 equals 16, or we get 2 times 8, which would equal 16. All right. So when we come to class tomorrow, we're going to continue looking at the distributive property and how it's applied. But what we really want to get into is when we start looking at the distributive property in terms of 2 times x plus 4, we can't just add the x and the 4 together. So we would take 2 times x. Okay, we're distributing that 2 to the set x, and then we're going to add the distribution of the 2 times 4. So plus 2 times 4, and that would give us 2x plus 8, and then we're able to move on from there, especially if we know what the area should equal. Okay, so this is the ultimate goal of the distributive property, is be distributing that 2 to the x plus 4, and then being able to work with the equation from there. All right, again, if you need to watch this more than once so you can pick up on it, that's fine. There is no problem due tomorrow when you come to class, so just make sure that you have a very good understanding of the distributive property.